Okay, so good evening, everyone. This is Team Area 52, 18227, and this is our fourth STEM forum. We have a special guest today, Matt Guckenberger, and he is an aerospace engineer for Lockheed Martin. He has a PhD in aerospace.
No, 我要开咪。
Oh, okay. He has a PhD in aerospace systems engineering and an MBA focused on strategic innovation and leadership. Mac has been part of the FIRST robotics community for the past 16 years, spanning across SLL, FTC, and FRC. The things he enjoys most about the FIRST program is teaching and being inspired by the next generation of STEM students. He is also actually a mentor of our team. We're very lucky to have him. And his topic today is finding your inspiration, the many paths of engineering. So without further ado, everyone please help me to welcome Matt Guckenberger.
Perfect. Thanks so much for the introduction, Sophie. Like she said, my name is Mac, and I'm going to talk today about the many paths of engineering. And when I tried putting together this speech, I tried focusing a little less on exactly what each engineer does and a little more on the questions I had once I would always talk to people about engineering. So without further ado, I'm going to start with a little bit of background about myself, which we got into a little bit, but hopefully this gives a little bit of credibility to what I'm saying. And if nothing else, might prompt some questions that you guys have at the end. So at this point in time, I have the chat open. So if you want to type a message or interrupt me at any point in time, please don't save those questions till the end, because sometimes you end up focusing more on your question because you don't want to forget it about some topic on slide 3. And so you miss some of the other content. So if you want to ask your question mid-presentation, just raise your hand or post in the chat and I can pause and you can ask it in person or type it out. Otherwise, I plan to end early and we'll have some time to talk about it then. So starting my timeline, I started out interested in engineering in middle school when I started joining the local FIRST robotics program. At that point in time, it was actually VEX Robotics instead of FIRST Tech-Trix. They switched over sometime when I was in high school, so it changed programs. And so at that point in time, I started mentoring VEX and participating in VEX. And then when VEX became FIRST Tech-Trix, FTC, I started participating in that. And our high school team had FIRST robotics competition. And if you guys haven't gone to see one, I highly recommend. So a little bit different design problem. FIRST Robotics builds a 120-pound robot from scratch each year. Whereas FTC, of course, you're all very familiar, and it's more structured, and you kind of start from the materials and a little bit smaller. So different design problems, different design engineers, a little bit different hands-on experience levels for the two different robotics programs. But I participated as a student for about 6 years, and then I continued mentoring it because I just really enjoy the program and I enjoy helping the students and kind of giving back all the things I learned. And so out of that program, I met a owner of a company called Components, and they made custom manufactured furniture and point of purchase displays. And you can kind of see that on the bottom. And so with that connection, a little bit of networking there, I ended up with my first internship before I ended up going to school for engineering. So coming out of high school, I ended up with my first internship working in engineering. And I did computer-aided design, which you can see on the bottom. And so I was working to design their office furniture that we would have CNC milled. And so we would sell these custom pieces of office furniture or sell these sales devices. So if you've ever gone into like a shoe store and you see those shoe racks that display all the different things, the lighting and built-in, that's what we built. And for a number of different customers, and we shipped them around the country. And so that's what I started out doing. And that reinforced that I really wanted to do mechanical engineering. And so I went to University of Wisconsin-Madison for my mechanical engineering degree. And while I was there, I worked for a company called Spectrum Brands, You might not know the Spectrum Brands company, but odds are you know some of their products. They are one of the biggest consumer brands, or they were at least. And so some of their consumer brands are George Foreman grills, Black & Decker appliances, so toaster ovens, toasters, blenders, things like that. And then they had Remington hair care. So hair dryers, hair straighteners, hair curlers, that type of thing. And so I worked in the research and development arm, and I designed grills, most things that heat up. So that grill is actually one that I have a patent on while I was there. And then that toaster oven, I helped redesign when I was there. And so we reduced the number of knobs on it to make it more or easier to manufacture, a little bit cheaper to manufacture. And we actually improved it overall, which is interesting because it was an effort to reduce costs. But while we were reducing costs, we actually optimized the way it worked. And so it actually preheated faster, and it was more even for toasting and such things. And then the toaster, we wanted to make faster toast. And so that was the whole thing. We built a whole device to figure out how to best speed up toasting. And so that's what I worked on. I worked on appliances for my whole time through undergraduate. I interned with them 3 summers, and then I worked full time for almost a year. And I decided that I wanted something a little bit more, and long term, I wanted at least a little bit more schooling because I wasn't quite done. And so I came down to Georgia Tech for aerospace engineering, systems engineering, and I did my master's and PhD. And then while I was there, I wanted a little bit more business experience from my time at Spectrum, and we'll get into a little bit on that. I worked with a lot of engineers who knew the business side, and so I wanted that understanding. And so I did my MBA with Scheller College of Business while I was there. As a student in engineering, for grad students, it's very common that you either become a teaching assistant or a research assistant. And so I was a research assistant and worked at one of the labs called the Aerospace Systems Design Laboratory. And basically we did contracting. And so I did a number of different projects for NASA, the Air Force Research Labs, and the Office of Naval Research. And that eventually gave me my interest in defense, and now I work for Lockheed Martin. So I kind of continued what I was doing in school, and now I work for Lockheed Martin, and we'll talk specifically about what I do at the end. But that's kind of my timeline and my history, and so where I got started in engineering. And so I've touched manufacturing, and I've touched the R&D world and aerospace and consumer products, and so I feel like I've seen quite a bit of different things pretty early in my career. So overall, that brings me then to this overarching question, which I'm sure everybody's wrestled with a little bit or has a basic answering to, which is, so what's engineering, and why do I care? And if I were interested in engineering, what does that mean? And so on the right, I have, of course, that wheel that has as many of the different engineering things as whoever put that wheel together could think of. But every year or every few years, there's a new one coming out. So mechanical engineering used to encompass aerospace engineering, and then as it became bigger, aerospace became their own. Or textile engineering, I think, is one of the newer engineering disciplines. And there's plastics engineering now, right? So as a field gets bigger, there starts becoming enough content in each one that it becomes its own. And so how do you pick amongst all of these? And even if you could pick amongst them, what does that mean? And so overall, I grabbed the definition of engineering from Wikipedia, which is the use of scientific principles to design and build machines, structures, and other items. And you can tell from that question or from that sentence, it still leaves you wondering. And it's very clear how you can have all of these different disciplines, right? Because if you apply scientific principles to civil architecture, so think bridges and buildings, then you're a civil engineer. And if you're trying to understand how to design and build planes, then you're an aeronautical engineer. And so you end up in all these different disciplines just based on what scientific principles you're slightly learning. But that really doesn't answer, in my opinion, at least, what does an engineer do? And what do I want to do if I were interested in engineering? And so overall, to emphasize this a little bit more, it's STEM by the numbers. This was done by Congress in 2017. But overall, this is the STEM degrees. And you're looking at just over 6 million people, right? And so when there's that many people in any industry, it really doesn't matter what industry you're looking at. We don't all do the same thing. And even if you break us all apart, if you looked at all the mechanical engineers or all the aeronautical engineers, they don't do all the same thing. So when you start asking an engineer, hey, what do? You have to understand that we're all doing something a little bit different. And it's all based on what we were interested in or what we kind of learned over time. So I want this to emphasize just the variety of people that join engineering and kind of where they end up. And in order to talk through at least my breakdown of engineering, I want to start with this product life cycle. So when we talk about the stages of engineering, this is what I'm going to use to talk about all those different types of engineering. So when we went to the engineering wheel, where there's biomedical engineers and mechanical engineers and aerospace engineers and all these different types of engineers, and all of them are applying design principles to building things and improving things. This is kind of what we're talking about. And it really doesn't matter what product you apply here. Some fit a little bit better in this, some don't. We'll talk about how computer science is a little bit different sometimes than this, but most have this waterfall effect. So they start kind of at the top under concept, and then development, prototype, launch, and go all the way around until your end of service and your cycling. And so I put some devices on the left, right? And if you look at all these, you can kind of think how they move through this cycle. So if you're talking the iPhone, I mean, especially if you talk the first iPhone, it was, how do I make communication portable? How do I bring that computer to more people? And that's the concept. That's all the concept is I just want to bring this device to people. You don't necessarily have the idea fleshed out. You're just working through those requirements until you get to a prototype, and you have a successful prototype, and then you launch and manufacture it, and then becomes out in the masses. And then now you have to deal with sales and returns and service and the Apple shops, the geniuses. Similarly, if you're talking a plane, right, starts from concept, works through development, early prototype, all the way until we produce it and sell it. Robotics. I left a bridge just to emphasize civil engineering and some of these other engineering disciplines that I'm not going to focus on as much, follow a somewhat similar process. If you're talking, hey, I want to be able to get from one side of a river to another, right, you're going to start with a number of different bridge designs. You're going to pick one based on costs and capabilities. You're going to lay it out, and you're going to see a lot of different ones. Eventually, you're going to build it, manufacture it, and then actually use it, inspect it, and eventually you have to get rid of it. I mean, over time. And so even things that are bridges and buildings, which we don't always think about, all still go through this life cycle concept. So I'm going to use this to break it apart into 3 pieces. So we're going to break it apart into a research phase, a supply chain phase, and a customer relationship phase, and talk about kind of how different roles of engineering fit into each of them. And the goal of that is to really talk about what interests you, because over an engineer's life, they will typically bounce between a few different areas, but overall, a lot are guided or intrigued by a few subsets of these, and they focus on that. So if we start with research, which are going to be our first 3 elements of a product lifecycle, so concept, development, and prototyping, this should be the one that you're probably most familiar with FIRST in general. First Tech Challenge, First Robotics, doesn't really matter. You're going to end up kind of in this phase. So you're looking at this for a company and a number of different companies. These are kind of the roles, at least at a first pass, that I see engineers doing. Now, there's more breakdown that could be done here, but at least hopefully it gives you an idea. If one of these catch your eye, we can talk about it more in depth. Or if one of them intrigue you, then maybe you want to talk to some engineers that work in this area of research. So the first area of research is a technologist, a technology roadmaps and research. Think of this as your early development research. This happens a lot in academia. So when I was in school, this is a lot of early research. If you're talking about like 5G networks, right? Everybody's talking about the new cell phones, they're all going to be on 5G. Well, somebody had to develop the technology that actually transfers data over 5G, right? Or the concept of the internet. All of those are concepts long before they're products. And so up here is really your researchers doing, they like to term it fundamental research. This is research that is used to build other things. So when you're looking at electric cars, right, battery technology might be part of the fundamental research category and used up here in technology roadmaps. If you know you want to build a car in 5 years, then you need to have some fundamental things here, or you might improve my miles per gallon in an engine, all of that belongs up here. The next one is a requirements definition. So I didn't really have a great category for these two because they're a little bit hard to describe. So I just gave examples. But if you're talking the iPhone 13 specs, so actually what is that iPhone 13 going to do? This, again, is typically an early development thing where an engineer kind of sits with your sales and your marketing teams and breaks down exactly what that system is going to do. So we formalize all those requirements into a requirement sheet, and it says the iPhone 13 is going to have this much processing capability, and it needs to have this much storage, and it needs to have a screen this size, and then slowly those can change over time, but he manages those requirements of the system, and they're very early in the process. The second one, or the third one, then is going to be initial design and analysis. So this would be an area that sometimes you kind of experience in FTC or FRC, right? So initial design and analysis is going to be that computer-aided design, actually laying out that virtual model. Structural analysis for aircraft, it's also flight analysis, whether that's flight dynamics or aerodynamics. This is where all of those come in to make sure that that first development is going to succeed, and then we prototype. So the next step then is that prototyping. This can be a whole set of engineers. They're actually going to start designing that thing for manufacturing. So how am I going to build it? It's really cool to draw it up and say, oh, this is exactly what I'm going to do. And then somebody has to say, okay, well, that's fun, but I need to assemble it. I need to manufacture it. And so very early, this starts typically with rapid manufacturing, which is a really cool concept right now, but think 3D printing or CNC milling, that type of thing where I can automate that process, and then all the way up to a first piece sample. So this is going to be developed in a similar way that you're actually going to build the piece. And then lastly, once you get that prototype, there's a whole team of testing engineers. Now, when I say these 5 categories, you have to remember that depending on what we're building, these could be coupled or these could be very spread out. So we're going to look at a little bit later for aerospace in particular, but for aerospace, each one of these is a big team. For consumer products, some of these are overlapping. For example, like I kind of did prototyping and testing for George Foreman Grills when I was there. That was the area I liked doing, whereas somebody else did initial design analysis and requirements definition. So doesn't mean all of them are separate all the time, but these are kind of the categories that people will fall into. And so that testing focuses on bringing that prototype into a wind tunnel, stress test, environmental testing. So environmental testing is for a plane, it might be how much wind or how much rain falls on the aircraft and make sure that none of it gets into the aircraft. For grills, it might be a preheat test, making sure that it doesn't burn down when it goes to temperature, making sure that the thermocouples work to make sure that's regulating temperature. The coatings that are on it, making sure those work, that type of thing. So once you get through the prototype, now you're ready to start getting into your supply chain. So you're ready to start your launch. And again, if we use the iPhone as an example, right, they get that first prototype, that first piece sample, they kind of show it on the stage and they're like, this is what we're going to sell all of you, come pre-order my stuff. And now we're working into the launch, the manufacturing, and the distribution phases. So here where the engineers are involved is a few different categories. One of them is they work with our suppliers. So they work with the suppliers to manage raw materials. We need to make sure the right things are coming in. I know when I was working for George Foreman Grills, it was interesting because one of the plastics that we had gotten in, we had specified the right one in the requirements definition, but when the plastic actually came in, it was the wrong plastic. So there needs to be somebody technically capable that's working with those suppliers, making sure you're getting the right things, sourcing them, costing all of that out. You also have to make sure that there's 2 different suppliers. So if one had a fire in their factory, or maybe it snowed in the north, and so you can't get those parts, you're responsible for making sure that those subcontractors and raw materials are getting to the manufacturing plant on time. The next set of engineers kind of focuses on internal manufacturing. So these engineers are going to be responsible for improving manufacturing processes. And part of improvement is measurement. So you have to understand how your manufacturing processes are going. So cycle times, how long does it take a part or a subcomponent to move through your production floor? How much does it cost in raw materials and time? And what's the quality of that piece? And then overall, you're trying to improve those things. So how do I reduce the cycle time? How do I improve my cost metrics or improve my quality? And so that's really where manufacturing engineer is involved. So if you ever hear, they've reduced the cost of some item, whether that's like tape or, even our aircraft, right? So originally when an aircraft is produced, it typically takes, let's say a week. And then over time, as we produce that, our manufacturing engineers work to get that down to about half that time, so 3 days, 4 days kind of concept. Aircraft take a little bit longer than that, but that's functionally what they do and about the improvement that they'll end up getting. The next step's a quality control engineer. So you'll notice that there's testers kind of at every step. If you're interested in data and tests and seeing physical samples, quality control might be an interesting one. So instead of testing the prototype, now they're going to test the finished product. And they're going to test product samples throughout the creation of that product to make sure that the quality stays constant. Again, they're the ones that are going to check if a plastic's wrong or if there's debris in your aircraft when you're rolling it out the line. They're that final line that has ways of checking material hardness for scratches, defects, anything like that, and give an indication back to your manufacturing engineers of any failures there. The last one then is going to be your distribution. I call them distribution, but very often companies will call these your supply chain engineers or engineers in supply chain. This is really how I'm going to move product from my manufacturing floor to anywhere. So am I going to store it in warehouses? How much am I going to store? Am I going to store it on site? Do I need to move it to stores on their own? So you're really managing that product inventory, how to move it, where to move it, what box size you might need, and making sure it doesn't get damaged in transit. Okay, the last category then I wanted to get into is customer relationship. So these are going to be a lot more customer focused engineers for the most part. The top one I want to say is sales. I know this isn't typically a role necessarily that people associate with engineers, but there is a role called technical sales. Not all companies use them necessarily, but many companies do, or certain industries certainly do. For example, biomedical, and they use their technical understanding to explain products to potential customers. So very often a technical salesperson, like biomedical engineering, is going to go talk to that doctor to explain how this device could help them, or they might shadow them for a day to understand what that doctor is doing day to day to make sure that I'm getting you the right product that's going to help you. And their technical expertise allows them to really connect with that customer and provide that information that that customer wants. The next one's a sustainment engineer. They're going to focus on on-site maintenance and training. So they'll be sent all over the world if the company sells all over the world, or sometimes they can have regions. And they return products to initial capability, train new employees, and identify sources of improvement. So they're going to be a lot more customer focused. Again, that's the whole emphasis of this section, to understand how our customers are using things. So for Lockheed, because that's one I can certainly speak to, we send engineers everywhere where our aircraft are kind of flown, helping those trainers to understand that aircraft and maintain it, as well as any other data analysis that they need. The other set I thought was interesting. I didn't quite know the name for them, or at least I couldn't remember the name. A lot of companies have liability engineers, and they're an internal house typically to make sure you have a response to any legal claims. So if some part breaks, you want to understand how it broke, where it broke, and what caused that, and then they write reports. So again, like I said, there's testing at all levels. So at prototyping, there's that wind tunnel testing, there's that initial testing, then you have quality control when you're manufacturing, and on the tail end for customers, you have this liability role that looks at all returns and all failures of your product. And then the last one is going to be product recycling. So these are your end-of-life engineers that are looking for opportunities for reuse of costly, scarce materials. Anytime anything's taken down, we're always looking for reuse opportunities. And a great example here, right, would be looking at how Tesla's trying to repurpose their batteries, or if you ever watch when, you know, buildings are taken down, I mean, they're always trying to scavenge some of those parts. So there's got to be someone there then that's checking the viability of those parts and making sure that they're still good if you're going to reuse them, and how do you reuse them, and how do you take it apart in a way that allows you to push it back into your production line. So the last one then were roles that I couldn't fit anywhere else, but are very important to product lifecycle and might be interesting to you if you don't like being at one of those levels. So one of them for engineers is a project manager. They actually manage the project deliverables. So you can imagine if you take this whole product lifecycle, or even a category of it, if you're doing research, so that concept development, prototyping, there's got to be someone for your team that makes sure all together you're going to hit deadlines, and all together we're working towards requirements definition. And that's a full-time job. And so that's what the project manager does. He truly makes sure that that project is on track to hit the company's goals. The next one is a new product development. And I saw this role much more at Spectrum Brands, and because the pace of consumer products is very quick. And so we had these roles of engineers basically that bring together sales, marketing, and engineering to make that technology roadmap we were talking about a little bit earlier. So what should I be researching? This makes sure that sales and marketing are kind of guiding engineering efforts. So you need to have somebody bring together those three teams that say, okay, marketing, where do people seem to be interested? Sales, how much do you think I can make there? And engineering, can I do that? And all of them kind of come together in one room to say, okay, here is my technology roadmap. So where do I plan to be next year, and where do I plan to be in 5 years? And then together, that's what we work towards. And so they pass that off to your project managers, and that kicks off a whole bunch of product life cycles. Other overarching roles, if you're intrigued, right, upper management is filled with engineers. The technical expertise, the know-how, the knowledge, the background, all make great opportunities to move up, just because you're managing a lot of technology. And the easiest way to manage engineers and technology sometimes is to be one, because you understand what those roles take. The last two are just fun pivots, I guess. I didn't find out about until later in my career, although it wouldn't have changed things for me personally, but I certainly want to pass them along. There's a lot of consulting companies out now that do engineering consulting. A lot of them are going to focus on specific parts of that product lifecycle. So certain engineering consultants are going to focus on that research area, or manufacturing, or improving end of life and customer interactions. Some consulting firms are big enough that they do all of them, but still, as an engineer, most often you're going to end up in helping in one of those buckets for short times. You can certainly move between them, but engineering consultings help fill these gaps when companies don't have the capability internally. And then the last one, which I just find interesting, is a patent attorney. So patents protect intellectual property. So if you design something cool and novel, you can write up a patent to make sure nobody else can use it. Typically that's owned by the company if it's developed by the company, but either way, it's still cool to have one. And when you type that up, you supply it to the government, and patent attorneys look over it. And those are required to have a technical STEM degree, because you're looking over this document that says, this is my cool new invention, and I need to understand what that cool new invention is to determine whether or not it's novel and whether or not I should allow you to protect it. So going through all the different engineering disciplines, or I shouldn't say disciplines, different engineering roles, overall, hopefully you realize that engineering, it takes a team. Doesn't matter what we're looking at, whether we're talking about grills, robotics, or planes, all systems are too big to be designed by one person or a group. Phones, bridges, everything has a team in engineering. Each group brings their own important expertise and experience and tools. And then there's got to be somebody that brings all those groups together. And so that left those overarching roles. Okay, Ryan, I see your question. I will hit that in a second. We'll talk about it at the end in what I do. But I'm more than willing to talk a little bit about that one. So for engineering takes a team, I don't know if anybody's seen kind of the graphic on the right. There's a lot of different variations on this. But basically, if each group was in charge of designing the plane, that's roughly what the plane would look like, or that's how the joke goes. So if you look at the controls plane, it's very easy controls. If you look at the weight group, right, it's super lightweight. It's all made out of balsa wood and microfilm, so it weighs nothing. The hydraulics group left all the hydraulics visible and easy to deal with, right? They all focused on maximizing their own preferences and experience inside that group. And so somebody brings all of these things together to make sure that hydraulics works with the controls group. So we have both a reasonably weighted plane with good controls, good hydraulics, and all these groups kind of come together to build that final aircraft. You see similar things in robotics. I'm not sure how much your team can relate, but most teams can, that you typically have some people that are in charge of controls and programming and electronics and mechanical. And all of these groups want time with the robot. And we don't necessarily understand what the other group needs that's always getting in my way, right? So the programmers want to have the robot so they can, program in the new autonomous mode with the new sensors. Yet the mechanical group's like, oh, hold on, I'm still adding this new thing, or I want to fix this final part. And so together you have to come together as a team and split those times to make sure that overall that system succeeds. So talking a little bit about my engineering background, preferences, and where I am right now. Right now, my role is called a military operations analyst. So my job function is military operations analysis. And this is because I really enjoy research and development environments. And so if you ever see the term R&D and you're not familiar, that's what it stands for, research and development. Whether I was at Spectrum Brands working on grills or military operations, that's what I really enjoy doing. So military operations analysis, the little picture on the right, is understanding how a system performs in its operations to define requirements. So said a little bit differently, basically I build a video game, which you're kind of seeing in that picture, where there's little red planes and little blue planes, and they fight against each other. And I modify things such as one run might have 4 missiles, and one run might have 6 missiles, and one run might be able to go 500 miles, and one run might be able to go 800 miles. And one run might be able to turn this quickly, and one run needs to turn slower. And overall, we look at all of those different metrics to help the customer understand their requirements, right? So if you need to carry more weight, it might cost more. If you need to go further in range, it might cost more. But at some point, that range isn't getting you much. And you can certainly see this in commercial aircraft. When you look at Delta or American Airlines or any of the big planes, right? They've all decided what size aircraft you should be on. Not everybody's flying on the big 747 or the big A380. They have smaller aircraft for their smaller routes that are all sized for the number of passengers. And that all kind of comes through an operations assessment of how many people do I think is going to be on that route? How many tickets can I sell? How much revenue can I make? And so that's what I do. The reason I love doing it is because it's high level, full picture engineering. That being said, I can't answer the detailed questions you want. So if you specifically want to know how that radar works, I would have to refer you to a radar engineer. That's what they do. That's what they design all day long. I know generally kind of how it works. I could not tell you, how that cloud impacts it versus that cloud, but I do know clouds impact it. I know the overview of a lot of these systems, and that's what I enjoy. The other thing operations analysis allows me to do is balance the business and technology. Because like I said, we're trying to make that business case to a customer to understand, what type of requirements you want on that plane. And so therefore I'm combining my engineering knowledge of that assessment with the business case in that MBA. The other question I feel like I always had going into any engineering discussion was, what do you do day to day? And I don't know if anybody's asked that question, and depending on who you ask, you get a different answer. A lot of the time, I feel like that answer is it depends, and at least I didn't find that super helpful. So if you want to know my current time split, it's about 70% coding because I'm designing this little video game here, 20% teaching new employees how to use this program, and then about 10% presenting to different customers. But when I was at Spectrum Brands, it was a little bit different. I wasn't coding nearly as much. I did a lot of, like I said, that prototyping level and that testing. And so I was probably 50% prototyping and 20%, 30% on my computer. And then I was really early in my career, so I really didn't do teaching. But that last little bit, I was presenting to my bosses and working with my team. So what makes an engineer? It's certainly not the field for everyone, but it can be for anyone. So I'm not trying to say that engineering should be for you, but if you're at all interested, certainly then it can be for you, because that's really all it takes. To me, engineering is just an interest. So you have to be imaginative, you have to be compassionate, you have to be engaged. I mean, at the end of the day, we're trying to design and improve something. So it's really all about what interests you. Where do you want to be? Where do you think that creativity is going to spur some interest? And then other than that, it's all about teamwork. So cooperative, helpful, open-minded, determined, all those traits of just being a team player. Like I said, engineers all work on teams, whether you're talking about one sub area, so a structures group or an operations analysis, right? I work with other operations analysis team members, and then I also work with my manager and structures teams and stuff like that, because we have to understand how our aircraft is actually working. So teamwork is definitely a key thing. If you'd like to be more solitary, then engineering isn't necessarily the greatest of fields. So my conclusion side then is certainly I can only speak from my experiences. This focus, I hit certainly a little bit more on the aerospace mechanical engineering just due to my background, but most concepts hold across many fields. So my brother and his wife are both PhDs in biomedical engineering, so I'm very familiar with some of their field. My younger brother is a software engineer, and so I'm somewhat familiar with that. My fiance is a product manager. And so I've touched a lot of these different fields and even showed some of them this PowerPoint, and a lot relate. They're just very similar. So when you start looking at different engineering disciplines, you should really ask yourself two questions. What am I interested in product? You know, do I want to be more research heavy? Am I really enjoyed how things are made? Do I want to interact with the customer? And then the second question is, what area do I like designing? And that doesn't mean you don't have to change. But overall, it's always a good start, because that's going to be your schooling and your expertise. So if you really like electrical, be an electrical engineer. If you really like mechanical, be a mechanical engineer. If you really like medical things, be a biomedical engineer, right? There's so many different areas just to get that design expertise. And then from there, there's all of these different roles inside of that career field. And lastly, FIRST provides a whole bunch of great insights to many of these engineering disciplines. Many of the teams work with a variety of engineers, and that should be further emphasizing the fact that it really doesn't matter what type of engineer you are, as long as you're interested in it. Because if biomedical engineers can design robots just as well as aerospace and mechanical and all of the other ones, then certainly it goes the other way, right? So that provides a great network of mentors for excellent resources. So just start a conversation with them. Any of them really that you see at any competition, just ask them about the background, and you got some questions, and hopefully this can give you a starting point. So from there, I'm going to answer the two questions I see in the chat so far. We're up to 3. And so I will hit those, and then I will just kind of keep going. So first caveat I have to give whenever you're answering questions and work for a company is basically I don't speak on behalf of the company. Can't really give you anything specific to that. So these words are mine alone, my opinions. So just know you're speaking to Mac, not anybody on behalf of Lockheed. So the first question was, what was my role in Artemis 1's recent launch, and what do you think about the future of new space exploration era? So my role in Artemis 1's launch was none. And it was really cool when I was still in grad school. I did one project with NASA, and we were doing a costing understanding for future launch vehicles. But right now I switched to, you have to understand when you're looking at certainly the military side, but kind of all of aerospace, it's really 3 different areas. One of them is aircraft, which splits into defense and commercial. And so you can be interested in one or the other. The other one is missiles. And the reason they're separate is because their speed and the way they actually fly is very different from aircraft, structurally, guidance, all sorts of things. And then the third category is space. And it's entirely separated, whether you're talking satellites or launch vehicles. And so I work on aircraft. That's all I've really done, certainly since grad school. But what do I think about the future of new space exploration? I'm really excited. I think there's so many technologies that come out of these new exploration opportunities. I know, like everybody on this call, all you've ever seen is videos of them landing on the moon. So I think it's cool. I think there's some cool opportunities, and I'm hopeful that it provides opportunities into the future, but it's not something I touch. When I want to design a new product or a new feature of the existing product, how do you find good ideas to start with? And at what point you can confirm your idea is practical and you shall move forward, or it's not possible to realize and have to change the next idea? And when you are not sure about something, or you think the idea is valid, but it's beyond your knowledge level, what should you do? Oof, that was a lot of good questions all in there, all at once. There's many ways to break that apart. So when we talk about how do you find good ideas, there's a whole bunch of places to start. If you're talking internally, start asking yourself questions of, I wish I had, I don't like that. And always start from what is the problem. Never start from the solution. What are you trying to solve? And then try thinking through as many solutions as possible. It's really where you want to be starting. Now, sometimes if you're talking at home, you can start answering those questions. Or if you have a class, right, that's where you're going to start that problem. I keep a running note on my phone, just in case I was curious, on random things I think of throughout the day. So if I ever get the inspiration and want to do my own product development, that's where I start. I just have a list of things that I get frustrated by or think might make sense. And so it gives me some innovation. If you're talking for a company, we start from 2 avenues. One is going to be our internal corporate research, and the second one is going to be a customer request. So internal corporate research is going to constantly look at what people want. If you're talking fashion, it's the next year's fashion, right? If you're talking appliances, we actually had next year's colors. Like they had these predicted color sheets of what people thought, or if you look at the change over time, like painted things were really in, and then it became stainless steel. And so some of our ideas was just how to keep up with what people wanted, whether that was healthy cooking or quick cooking, right? You're constantly adjusting to what that customer is requesting, and then working from there. What point can confirm it's practical and you shall move forward? So every company does this a little bit differently. Typically, it's some sort of a gate process. You kind of spend a little bit to prove its viability, and that little bit is all determined based on how much money they think they can make. So it's all risk reward. It's done by the business people, product managers, upper management, with their expertise, kind of determine how much we should put behind it, put some deadlines, and let's see what it looks like. One of the ways they do this is that technology roadmap I was talking about. So if we think we should be somewhere, and that kind of goes to that last question of what if it's beyond your knowledge level, then get a bigger team involved, and let's see what we think, or let's start developing things towards that. So if you don't have the proper computer processor today, okay, well, let's work past that. Maybe we'll have to add 4 processors, but in 2 years, we think the processor will be there. So we're going to start designing around that feature and plan for it to be there. Is defense making a significant transition to space-based operations? If not, will it ever become feasible? Will that alter what you do? How do I answer that one? It really depends what you call space-based operations loosely. And I don't know if it's really going to affect what I do, certainly not in my lifetime, because you just have too many world factors into account, right? So, I mean, if you go back, I don't know, 300 years, I mean, when do you want to claim we started kind of fighting wars and having armies, right? So when you progress forward in time, you started adding the Navy, you started adding the Air Force, and that didn't really make each level of defense go away. It just changes it and reduces its size and changes how it works. And so I do think we'll continue moving towards space. I think there's a lot of things that have already been done in space. One of them that we benefit from every day, right, is the GPS satellites that we get to use on our cell phones and our smartwatches and all over the place. So we've been using the space layer for a long time, and I think that's going to continue to improve. I don't see that changing what I do in any near time. However, it does leave more opportunities if I want to do space things, especially with the creation of Space Force, which, similar to the Army used to have Army Air Corps, and then air became too big, and so now we have the U.S. Air Force. It's kind of what happened there. So it is an intentional movement towards understanding space. Okay, would I say engineering is very hands-on, and what are your suggestions on improving building skills? Did you post again? Okay, so Annie, if you could post on the bottom, I'm curious what type of, or come off mute. I want to address the building skills, but I'm not quite sure what building skills you're asking about. So would I say engineering is very hands-on? I would say the less helpful answer of it depends, and the more helpful answer of it really depends on what type of engineering you get into, for one, and what you want to do. And then the second part is certainly there are lots of benefits to computers. So things that used to be hands-on are not necessarily still hands-on, but that does not mean there are not lots of engineering roles that are hands-on. And that's why I want to emphasize some of them. Wind tunnel testing, for example, or structural loading, or all of those testing roles are still very hands-on. There's still prototyping and research that's done in the field in the labs. There's roles all over if you want to be hands-on. The other reason that I question a little bit the hands-on is going back to my brother and his wife, right? They're both biomedical engineering PhDs, and one does manufacturing of like test samples, and so his background's mechanical engineering, and so he actually does hands-on test manufacturing and prototyping to build the test samples, right? Whereas his wife, she does cancer research, and so she is constantly working with those diseases, microscopes, clean rooms, things like that. Are both of those hands-on? Do you have one preference towards like a manufacturing hands-on, or is being in the lab also hands-on? Hopefully that provides a little bit more context on the different types of hands-on. Okay, and I will come back to improving building skills when I have more context. How does being able to talk in a public environment play into engineering? I would argue being able to talk in a public environment plays into everything, always. Now, it's not a requirement for anything, but the better you can communicate your ideas and work to communicate your ideas, especially across different things, the more capable you'll just be in general. And one of those I really want to emphasize is not just communicating to a technical audience. You have to be able to communicate those ideas that I have, whether that's a concept to business people or my marketing people or the CEO, if that's so who's in your meeting, right? everybody's got their own communication style. And so the more you can learn to communicate and break down ideas and not only talk through graphs, the better you're going to be. And so I recommend kind of working on that skill. Just in general, it's very helpful. Doesn't mean you need to start from anywhere, but it will help you throughout life. How has the developing rivalry between the US and other nations like Russia affected the need and type of defense strategies that need to be developed? I'm going to audible a little bit on that one, I think, and just say we kind of are always looking forward and we're always developing something. And we've been doing that for a very long time. And some of those are just meant to help everyone, right? I mean, whether you're talking GPS or some of the other technologies that came out, like the space race, it's just development that kind of needs to be done. But I would say that we're always looking forward. And as a contractor, we don't develop the defense strategies. That comes from our customers. So when I talk about customer interaction, whether I'm talking about consumer at George Foreman Grills or the government for us, they come and they say, hey, this is what we're thinking. How can you help my problem? And that's where my video game kind of comes in, is so we do that video game based on what they're thinking. Favorite part of working at Lockheed Martin. I really like operations analysis. I did not know that was a role before grad school, where I could kind of like develop my own video game and see how that works and play it out and watch this replay file of everything interacting and then change something and work with pilots. So I like the people I work with, the pilots I work with, and I like being able to kind of do that video game and seeing the high level of things. It's my favorite part. That being said, I also really like Spectrum brands. I'm very agnostic, indifferent towards what I'm building, as long as it's fun and interesting and challenges me. And so my reason for going back to school was I just wanted a little bit more of a challenge. Not that it wasn't, I just wasn't done learning. I was so early in my career that I wanted to change things up a little bit. Both environments to me are just very interesting and very different. Depth versus breadth in engineering. What's your suggestion on how to go about them? Any balancing act or sequence of approach? Depth versus breadth. Couple of comments on it. One is school is going to hit more breadth. I know it's not going to feel like it because they hit like calculus at 3 levels, that it feels very deep, but especially undergraduate degrees for the most part hit breadth. And I think that's very helpful for engineers. If you're trying to improve things, you have to understand a little bit of the world around you. And so that's definitely, in my opinion, one of the first balancing acts. After that, depth really comes based on your interest. So for Lockheed Martin, we kind of have 2 paths. One is the leadership path, and one is individual contributors. So we have technical experts, scientists, engineers, that they only ever want to be the subject matter expert in something. So whether that's a radar expert or a structures expert, that's what they want to do. So they're very, very deep in that category. And if you're interested in that, there's tons of career paths out there that just focus on going deep. If instead you're more intrigued, like I am, I'm a breadth person. I like seeing a little bit of everything. That's why I like consumer products. That's why I like operations analysis, is I can understand a lot of different elements, but I know I'm not deep at any of them. So then I need to build my network. I need to know all of those people so I can go ask my questions and understand. So the balancing act or sequence of approach, I'll say school's going to push breadth first. I like breadth first because it gives you the best understanding in what you want to go deep in. If you start going deep too early, then you're like, oh man, I don't like this area. You start getting a little more stuck. So start with breadth, understand what you like, and then go deep if you're interested, and there's career paths for both. Yes, I will say to the last part, experiments, test type of hands-on skill. That's kind of what I was thinking too. Experiments and manufacturing slightly different, just in my mind, just because I like hands-on experiments a little bit more. But 100% agree. The more you can be involved in actually touching and manipulating a system, or building a rocket that fails kind of concept, anything you build, whether that's through FTC or at home, or just get like a little hobby kit and start piecing it together, just helps to me with that breadth discussion. Eventually you can start getting a little more depth too if you keep doing the same thing. But those early experiments help a ton with breadth, and really helped me early in my career, and continue to help, but especially early. Yes, the last one. As an engineer, how do you manage your time, and what's your suggestions on time management on the robotics team? Since team members shall study, get high GPAs, and build robots, coding a lot of outreach activities, maybe also some extra curriculums. I couldn't have added many more bullets when I went through it. It was a challenge. I will agree. You have to do what's right for you. And you have to do what's right with your parents and your family, and everybody has different restrictions and capabilities here. Some people need more time to study. Some people need more time in different categories. I will say that my GPAs in my school have got me a very long way. So if you can't get past the GPA threshold in some ways, and I'm not saying that's a 4, I'm just saying that GPA is important. And once you get past that bar, curriculums and experience really start mattering. So you need to focus on school. It needs to be a priority. After that, whatever time you allow, and whatever time you think is going to grow. If you want my answer to that, I did a lot. After school, every day we would typically meet at about 6, because you had to wait till the mentors got off. And so we would meet from 6 to 9 p.m. Almost every weeknight. I think we had Wednesdays off, and like all day Saturday. And I did a whole bunch of extracurricular and other things. So I would stay at school from 3 to 6 and do my homework, and then I would go walk and get dinner, and then I would do robotics from 6 to 9. And so I certainly know the time commitment it can be, and that worked for me, but it doesn't work for everybody, and it didn't, and not everybody did that. So really depends what you think's getting useful time out of your day, and just make sure that you're prioritizing, family and school. And if you're doing those two things, then balance out the rest and find what's being helpful to you. I'm not here to condemn other extracurriculars, because all of them taught me a little bit of something. I did sports for a while. I also mentored vector robotics a lot through school. So I participated in robotics, and I would mentor elementary and middle school kids. And that taught me a lot. That giving back does 2 things. One, well, I guess 3, kind of makes you feel good. But what it really does is teaches you some elements of leadership. And the other one it does is it forces you to understand what you don't know. Anytime you have to teach a subject, if you've been tutoring or doing whatever, the questions that come up will very quickly emphasize the areas where you're really light at understanding. So if your answer has to be, well, you just do it this way, that's not in depth. You should have enough understanding to explain all the way through an answer. So if somebody's like, well, why do we need 2 bolts rather than 1, right? It's, well, 1 bolt would allow this part to rotate, or maybe 1 bolt doesn't have enough holding power to hold that together. Or if 1 got loose, that would be a problem, right? So you want to talk through a few of those issues so somebody else understands and truly learns rather than just imitates. And I found that helpful extracurriculars, but everybody has their own things, and everybody I did robotics with had a lot of different things. And when I got to school, every engineer I knew started with a whole bunch of different things. So it's not really a one size fits all.
Okay, so I think that's the last question. Yeah, perfect. Okay, so thank you so much, Mac, for sharing your experience and advice with us.
Yeah, thanks for having me. And if there's any other questions, feel free to reach out, and I'm more than willing to answer them. And of course, I'll be around this season to help talk through some of the other things. So it was great speaking to everyone. I hope you got something out of it. Loved all the questions. So really thanks for all the attention.
Yeah, I never knew there were so many kinds of engineering.
Yeah, biggest takeaway I have is there's types of engineering, and then there's all the different things we do. So when you're asking those questions of all the different engineers you meet, dig in a little bit more on what they do. Like, do you design the system, or is it once it's designed? And find what you like to do. I have friends who love manufacturing engineering. It's great. I can't do it. It just never interested me. So I started doing it a little bit out of high school, and then didn't go back to it. So everybody's got to find their own path. And if engineering is part of your path, then find where you want to be on it.
Yeah, definitely. Yeah.
Cool.
So thank you again for taking time out of your Thursday evening.
Perfect. Thanks, guys.
Thank you so much, Mac.
No problem.
And just let you know a good news. So last Saturday, we went to our first league, and actually we there's another kind of a ranking for the technical part, and I think we are ranking #1 in the United States right now.
Woo! Congrats. That's awesome.
Yeah. But probably will become a target of all the team right now, and we need to work harder to maintain that status.
Okay, challenge always. Oh, sorry. Last thing, I guess it reminded me because I finally looked down on my slide. The last thing I wanted to show, we went through the product development process. This little figure 8 thing is software development operations. Everybody has their own graphic, and there's a bunch you'll see out, but you can see how it kind of overlaps. Only weird part about software is they push it before it's fully finished. That's why you get updates all the time, right? So it's a little bit more circular and overlapping. I just wanted to emphasize some of the differences that do exist between fields, and that's why I put that there. So last figure to call out, awesome on the technology thing, and it was great getting to talk with everyone today.
Okay.
Thanks.
Thank you, Mac.
Thank you.
Thank you, everyone, to join us. I think we have a lot of community, the kids from community join us today. So I'm so happy that you can give them some inspiration to become an engineer in the future.
Yeah.
Always welcome. We welcome everyone.
Okay, bye. Have a nice evening. Thank you.
Have a great evening.